Hi, my name is Nathaniel Converse, and I'm an undergraduate student at the University of Nebraska at Kearney, and I'm studying applied computer science. I'm set to graduate at the end of this week. This semester, for my artificial intelligence course, I've been studying neural networks for audio deepfakes. So the first question is, what is a deepfake? You're probably familiar with the technology when you've seen a YouTube video of someone using machine learning to project someone else's face onto their own. And that would be like a visual deepfake, right? Well, what I was specifically interested in was an audio deepfake or synthetic voice cloning, where you could create a system that would be able to take the characteristics of your voice and recreate it and make you say anything you wanted to. So each of us have our own unique voice signature. And if you were going to create the most simple system to clone your own voice, you would have to have two individuals, each recording a data set where they said the exact same things thousands of times over, different lines, but each time they're saying the same thing as each other. And then you could take their voice recordings and turn them into a spectrogram so that the computer could understand them, and feed one person's voice recordings into the neural network and have it try to recreate the other person's spectrogram. If you did this thousands and thousands of times, by the end of it, you would have the ability to give it a recording of the first person, and it would turn it into what sounded like a recording of the second person, even if the second person had never said it, and you would have successfully created a deepfake. However, a research team at Google came up with a much simpler way of doing this that doesn't require recordings of both people for thousands of hours. In fact, it only uses about a 5-second recording of the voice that you want to characterize, and then some text input. So the way they were able to do this was a system that uses 3 combined neural networks. First, a speech encoder, then a synthesizer, and finally a vocoder. The speech encoder actually borrows technology from voice identification, where it's able to pick out specific unique characteristics of an individual's voice. Second, the synthesizer takes the text that we input and creates a spectrogram that represents a speech recording of that text. So it's a text-to-speech synthesizer. Simultaneously, the synthesizer takes the information from the encoder that uniquely identifies the input voice. So the speech that it synthesizes is actually similar to the voice that we input the recording of. Finally, the vocoder takes that spectrogram and translates it back into an audio waveform instead of a visual image. This is similar to how the Griffin-Lim algorithm works, but in this case, the Google researchers used a third neural network called WaveNet to specifically convert the synthetic MEL spectrograms into time-domain waveforms like we hear. The experimentation that I've done with this technology has all been based on an open source GitHub that was posted by 2 researchers who have been trying to recreate this Google research paper using open source data sets to train all 3 of the neural networks. I created a Google Colab that imports this repository and their pre-trained models so that I could feed it new audio and text recordings and see how well it worked and what changes could maybe improve it in the future. Here's an example of my voice being synthesized.
Thanks for checking out my artificial intelligence project. This is a clone of my voice that has been synthesized using 3 separate pre-trained neural networks.
And here's an example of Paul Bettany, the actor who plays Jarvis in the Iron Man films, being synthesized.
Maybe I am a monster. I don't think I'd know if I were one. And not what you are, and not what you intended.
Hello, Mr. Stark. My name is Jarvis. I am your virtual personal assistant.
I was specifically interested in trying to get this system to recreate the voices of people with English accents from the British Isles. And this system in particular, with these pre-trained models, has a hard time doing that because it's been trained almost entirely on North American accents. However, the Google researchers had an internal data set from Google, presumably voice recordings from all of their users, and they were able to recreate a variety of accents much more accurately. However, since this is really good at doing North American accents, here's an example of it synthesizing our professor from this class.
We're going to go through and try to work together on the machine learning project.
Hello class, I just wanted to let you know that Nathaniel did not get permission to use my voice, and I think this is really creepy.
This is some information about the pre-trained models that I used in this project. They were created by a GitHub user named Bluefish, and here he lists the data sets that he used. As you can see, primarily it used LibreSpeech and Vox Celeb, and both of these are data sets that are primarily North American accents. So in theory, you could do the same thing with any number of languages or any number of accents, and it would be able to recreate those voices as well with the same technology, and the only limitation is the data set. Here's an example of a voice that was synthesized using Google's internal data set.
The Norsemen considered the rainbow as a bridge over which the gods passed from Earth to their home in the sky.
There were many editions of these works still being used in the 19th century.
Here's an attempt at that same voice using the open source datasets LibreSpeech and Vox Celeb.
There were many editions of these works still being used in the 19th century.
As you can hear, the Google dataset is much more accurate, and this is largely because it has over 18,000 different speakers, as opposed to the 1,000 to 8,000 different speakers that the LibreSpeech and Vox Celeb datasets have. When it comes to neural networks, the more data you have, the more accurately you can recreate it. Obviously, this technology can be very frightening because it's something that we haven't been able to do before in human history. And with all the recordings that large corporations like Google and Facebook and Amazon have of our voices, it's easy to imagine that they would be able to quickly and easily synthesize our voices in a way that would be extremely convincing. I think that in the future, this will be somewhat normalized, where we as a society are aware that this is a possibility. Photoshop, for instance, has had a lot of discourse about whether or not it's good or bad for society, but at the end of the day, now that we are all aware that an image can be faked, society has come up with ways to adapt to it. And I think that the world will have to come up with a way to adapt to this as well. The only way that we're going to adapt to it is if we're aware that it exists. So if it's not something you were familiar with before, I hope that I've successfully brought it to your attention, and thank you for taking a look at my research project.